Hi guys, it's Miss Griffin. Today we are taking a look at Unit 2, Skill 4, Parallel Lines and Angles. Now Miss Wesley did take you through some of these parallel lines and angles back in Unit 1. I'm going to take you through them again, just a little bit more in depth, and then we'll actually do some finding angle measures with parallel lines. Our essential question for today is going to be, what special angle relationships are formed by parallel lines cut by a transversal? What special angle relationships are formed by parallel lines when cut by a transversal? So we've got this picture over here off to the left-hand side, and we've got some words in bold and italics over here off to the right. It says, if parallel lines are cut by a transversal, let's just break those words down for a second. Parallel lines, never intersect. And a transversal is just a line that crosses other lines. Okay. So if parallel lines are cut by a transversal, then 4 different special angle relationships are formed, with the first one being alternate interior angles. So we're going to break that down. You can see that it says the word interior. That means inside of your parallel lines. So I'm just going to kind of shade this area. If you have colors, it's very helpful to be using them right now. We'll say that this is interior. And then we'll just go ahead and talk about exterior right now. Exterior means outside of your parallel lines. If you have a different color, use it like I did. Exterior is outside the parallel lines. So if we have parallel lines cut by a transversal, then the alternate interior angles are congruent. Now, if we're talking about interior angles, then that means we need to be on the inside of our parallel lines. And then to be alternate, that means alternating sides of the transversal. So if I start you off with angle 3, wow, that's way too big. If I start you off with angle 3 here in orange, we need its alternate interior angle. And alternate interior angles are formed out of a Z, where we focus on the angles in the crux of the Z. So I can take and make a Z encompassing angle 3, then that means that its alternate interior angle is angle 6. So we'll say angle 3, comma, 6. Or we could have also talked about the other pair, angle 4, making that backward Z this time, with angle 5. Okay, so I'm just going to erase that stuff. I'm also going to erase my interior, exterior, if I can. Nope, I can't. Okay. Then we have these angles called alternate exterior angles. There's no letter like the Z that these form. We just have to think about the phrasing here. Alternate exterior angles. And these are also congruent to one another. And I'll give you a trick for figuring out congruent angles in just a minute. Alternate exterior, that means starting on the outside. So if I start you with angle 1, its alternate side would be all the way down here with angle 8. Alternate exterior. So angle 1, comma, angle 8. Or see if you can find the other pair there. Again, start with the outside, so something like angle 2, and then pair it up with its alternate exterior angle, angle 7. We have another pair of angles called corresponding angles. Corresponding angles we have a phrase for, meaning match up. These angles are also congruent, and they are angles such as angle 1 and its matching angle from the other set of angles. So if I take this set of angles up here and plop them down on top of the bottom set of angles, where does 1 end up falling on top of? Hopefully you're seeing that it would fall on top of angle 5. So we would say angle 1 and angle 5 are corresponding angles. If I start you with angle 2, think about where its corresponding angle is. Angle 2 matches up with angle 6. Or if I start you with angle 3, where would you say that its corresponding angle is? Again, if I take this top set of angles and plop it on top of the bottom set of angles, where would angle 3 fall on top of? It would fall on top of angle 7. Or, last but not least, angle 4 with angle 8. Then the last type of angles that are formed are same side interior or same side exterior angles. And these are actually supplementary. Remember, this means that they add up to 180. So an example of same side interior would be formed out of a C or a backward C. So like angle 3 with angle 5. Or we could have gone with same side exterior, angle 1 with angle 7. So they're on the same side of the transversal, but they're exterior angles. Now I told you I'd tell you a trick about whether they're congruent or supplementary. And I want you to, if you can, label your picture with me over here off to the left-hand side with A's and B's. Follow as I do. Starting with angle 1, we'll label it with an A. And then angle 2 gets a B. Angle 3 gets a B. Angle 4 gets an A. A, B, B, A. And we're going to repeat that sequence down here at the bottom. Angle 5 is an A. Angle 6 is a B. 7 is a B. 8 is an A. A, B, B, A. A, B, B, A. So now we're going to write ourselves a note about that. Angle A is congruent to angle A, of course. Angle B is congruent to any other angle B's. However, when we have an angle A and an angle B together next to each other, it's equal to 180. And we'll see this play out in 10 seconds. If we come back to our alternate interior angles 3 and 6, 3 is here, 6 is here, they're both B's, so they're congruent, right? Just like we said. Then if we come to, say, alternate exterior angles with angles 1 and 8, as we had pointed out, angle 1 has an A, angle 8 has an A, they're congruent. If we take a look at corresponding angles like angle 1 and angle 5, both have A's, they're congruent. However, if we look at same side interior angles like 3 and 5, one's an A and one's a B, which means that they add to 180. They're supplementary. Again, that pattern is A, B, B, A, B, B, A. So if you get parallel lines on your picture, you can certainly jot down that A, B, B, A and be good to go for figuring out whether they're congruent or supplementary. Now there is a little statement here that says if two lines are cut by a transversal and special pairs of angles are congruent or supplementary, then the lines are parallel. So it works in the reverse as well. If you have congruent or supplementary angles, then those lines could potentially be parallel. Example 1 says if M is parallel to N and the measure of angle 1 is 150 degrees, find the measure of the remaining angles and provide your reasoning. So we're going to work through this using some things that we've talked about previously, like vertical angles, angles on a line, but then we're also going to pull in some of those vocab words that we have up top, like corresponding angles or same side interior angles, alternate interior angles, so on and so forth. So, starting with angle 2. If I see angle 2 is sitting next to angle 1, where angle 1 is already 150 degrees, I know that on a straight line, they add up to 180. So off to the side, 180 minus 150 gives us 30. So angle 2 is 30 degrees. And our reasoning is that angles on a line equal 180. Okay, then it says number 3. Number 3 is opposite of angle 2. You can see that little bow tie happening there with those vertical angles. So we've got angle 3 must also be 30 degrees. And I'm going to say vertical angles are congruent. Okay, then we got angle 4 over here. Angle 4 is opposite of angle 1. I'm going to put 2 arc marks here because it's different than the 30-degree angle. Angle 4 must also be 150 degrees. And we can just repeat our reason here. Vertical angles are congruent. Next up, we've got angle 5. Now, angle 5 gives us a little bit of a trick here. It's all the way down here at the bottom, a brand new pair of angles. However, remember the fact that we have lines that are parallel. When you have lines that are parallel, always try to look for a forward Z or a backward Z first. If you can find it, that means you have a special pair of angles, being that they're alternate interior. So, although I highlighted the forward Z, what I'm really looking for to encompass angle 5 is a backward Z. So that encompasses angle 5 and angle 4, where angle 4 was 150. And if I think about my A, B, B, A, B, B, A, and actually drop it on here really quick, then I see that the 150 at angle 4 gets an A, angle 5 gets an A, so that means angle 5 must also be 150. And this is because alternate interior angles are congruent. Now you'll notice that I abbreviated. You are welcome to do the same as long as you know those vocab words. Alternate interior angles. Okay, from here we're going to find out what the measure of angle 6 is. Now we could certainly take 5 and 6 and be like, oh yeah, they add up to 180 and blah blah blah. But I don't want to do that. I want to force you to use some of the new vocab words that we've already learned. Or we've just learned, rather. Angle 6 matches up with an angle up above. Angle 6 matches with angle, fill in that blank there. Angle 6 matches with angle, hopefully you said angle 2. You see how they match up, they're in the same position. And they both have B's, which means that they're both congruent to one another, being 30 degrees. Think about which vocab word up top those angles must be towards one another. If they match up, then that means they're corresponding. Corresponding angles are congruent. Okay, next we have angle 7. Angle 7, again, I'm going to force you to use something other than angles on a line and vertical angles, because I know that you guys know, probably, I'm sure, that angle 7 is 30 degrees. Now let's come up with a reason that we haven't used so far. Angle 7 and angle 2 are what type of angles towards one another? Angle 7 and angle 2. They're on opposite sides of the transversal. They're on the outside of those parallel lines, so that means they are alternate exterior angles, which are congruent. And last but not least, we have angle 8, which is a large angle, 150 degrees. And we can use the fact that there's multiple options here. You have angles on a line, you have vertical angles, you have alternate exterior angles, or one that we haven't used yet, angle 2 and angle 8. Angle 2 and angle 8. Those are same side exterior angles, which equal 180. Same side of the transversal. They're on the outside of those parallel lines. And they're A and B, which mean they add to 180. Okay, I know it took us a while to get through this front side. We do have a little bit to do on the back side pertaining to parallel lines and finding angle measures. So flip it over. Okay, so example 2 says, given the diagram below with a pair of parallel lines, determine the value of angles A through G. So we've got parallel lines here, and the parallel lines are marked by this arrow on both pairs of lines. So our goal here is to find angles A through G. So starting maybe with angle A. If I look at angle A, remember our goal initially is to look for a Z or a backward Z because it always helps. When I see this Z, it's encompassing a 45-degree angle and the A, so that means that the A must also be 45 degrees. And that's because they are alternate interior angles. Maybe you want to jot that down off to the side. If you need to pause the video at any point, remember, do so. Okay, then let's just go for B next. B is over here, sitting by itself. Well, sort of. And I see that it's in a triangle, but I'm missing angle D, so I don't think that we can use angles in a triangle yet. And I don't have angle C to try and use alternate interior angles again. But B is sitting next to a 107, and they're on a straight line. Angles on a straight line sum to 180. So 180, take away 107, and we're left with 73. So B equals 73. And again, that was because angles on a line right here add up to 180. You can jot that down off to the side over here next to B if you want to. Okay, now let's go for C. C's up here. Oh my goodness, I just found a Z, a beautiful, beautiful Z, and it encompasses both angle B of 73 degrees and angle C of also now 73 degrees. Hopefully you are recognizing that the Z gives us alternate interior angles. Okay, next up we've got D. So D is sitting in this triangle. We have a 73, a 45, and then D. So we could use angles in a triangle sum to 180. Or it's sitting on a straight line with 73 and 45 again. So a straight line sums up to 180. It doesn't matter which method you use there, but we still have to add 73 and 45. Oops, 45. To get 118. And then from there, we're subtracting from 180. To give us, oops, lost my pen, to give us 62. Okay, next up, G. Oh no, not next up. I'm sorry, I skipped E and F. We've got E. Angle E. Angle E is sitting up here. I don't know. Take a look at the picture. Think about what you might be able to do. Angles in a triangle, angles on a line, alternate exterior, alternate interior. What can we do to find angle E? I'm seeing that it's on a straight line next to a 45-degree angle. So 45 plus something should give us 180. So 180 minus 45 gives us, sorry about that, gives us 135. Okay, next up we've got F. F, if you take a look at the picture, got a couple options, but there's one that's easiest. F is next to 135 on a straight line. So 145 on a straight line, well, that adds up to 180. Or, notice here that we have two straight lines crossing each other, making a nice, beautiful X. And in an X, we can find a bow tie. And in a bow tie, that means we have vertical angles. So F is 45 degrees. Vertical angles are congruent. Last but not least, we have G. G is sitting way down at the bottom here. Boom. It's also in a bow tie with angle B. In that bow tie, angles are congruent because of vertical angles again. So G equals 73. All right, example 3. I know that this video again is taking us a little while to get through, but the more that we explain here right now, the better off you're going to be when you get to your practice, just because there's so much that goes on with vertical parallel lines. So here it says, given the diagram below, with AC parallel to BE, now we should mark that. Remember I said marking parallel lines, we use these little arrows, AC parallel to BE, determine the measure of angle DBE. So I'm going to place an X here and then also up top in the question so that I remember eventually I'm trying to find X. So if we have parallel lines, we know that we can always look for a Z first. Boom, boom, boom. And whatever's encompassed in the crux of that Z gives us a pair of congruent alternate interior angles. So if this angle up here in the Z is 80 degrees, then this angle down here in the Z is also 80 degrees. And that's again because of alternate interior angles. If you want to jot that down, just pause the video real quick and jot it down. Then we also have another angle to still find out, because in order to find out X, we need all 3 angles on this straight line. So I need to first find this interior angle, CBA. Well, it's inside a triangle. So hopefully our brain's already thinking, well, I got 65 plus 80 plus, say, I don't know, Y equals 180. Go ahead and solve that for Y real quick. If you need more time, just pause it. I found that Y is 35 degrees. So now again, on this straight line, we can find X because they all sum to 180. So we have 35 plus 80 plus X equals 180. Take a second to solve that, please. Again, if you need more time, just pause the video. I found the measure of angle DBE, in other words X, to be 65 degrees. All right, there you go. There's all your vocab and the actual practice that goes along with parallel lines and the special types of angles formed. Don't forget, after your practice, you're going to come back and do your little summary here. And if you need to go back and rewind at anything during this video that you may have missed, then feel free to do so. Otherwise, adios, muchachos.